Okay, so in the previous video, I looked at the procedure to solve quadratic inequalities. Okay, but in this case, now I'm going to then apply this procedure into the actual problems. Okay, so let's look at example 1 here. Example 1, they say we must solve for x. The instruction is solve for x. They give us this inequality. They say 22x minus 121, it's less than x squared. Okay, that's what we are given. And then for 4 marks here, okay, they say here for 4 marks we must do this one. Now, as the first bullet point there in the procedure, it says you must make sure that this is in standard form. When you look at this, you can see it's not in standard form yet, so you must get it into standard form. So therefore, I want it to be 0. I want everything to be transferred to one side and have a 0 on the other side of the inequality. So I'm going to transfer the x squared to the left, and then it becomes negative x squared. Remember that something, when you move it to the other side, it becomes a negative plus 22x minus 121 less than 0. Okay, but it's not yet in the actual standard form that I know it, because the leading coefficient is negative. Okay, I want the coefficient of x squared to be positive, so I'm going to multiply throughout by a negative. But remember the note that I made at the top: whenever you multiply or you divide an inequality by a negative, the inequality sign must change direction. So therefore, you're going to say x squared minus, okay, you're going to change the sign of everything because you multiply throughout by a negative, plus 121. Now the sign must then point the other way. Okay, the sign must then point that other way. Then what do you do? Step number 2, you check if it has been factorized for you. By looking at this, you can see it has not been factorized for us. So you must then factorize it. Okay, we must then factorize it according to the procedure. So you must know how to factorize x squared minus 22x plus 121. That is a quadratic trinomial. So I'm going to find the factors x and x. The two numbers that I'm going to find, it's going to be, let's see, 121, 22, 11, and 11. Yes, 11 as well as 11. Okay, because 11 times 11 is 121. 11 plus 11 is 22. Okay, then the signs will be both negative there. Okay, and then after you factorize it for yourself rather, then get the critical values. Please don't say this. The procedure didn't say you must then take x minus 11 and say greater than 0, or the second bracket greater than 0. This is very incorrect. The procedure did not say do this. Okay, never do that. That is very wrong. Okay, according to the procedure, you have to get what? The critical values. You have to get things called critical values. Now, how do you then get those critical values? To get the critical values, you just say critical values. From the procedure itself, it indicated that to get the critical values, you take each bracket, okay, each bracket, and equate it to 0. So when x minus 11 is 0, you can solve for x. X is 11. Then the second bracket, by looking at it, you can see it's the same as the first bracket. So even if you take the second bracket and equate it to 0, you'll still get x is equals to 11. Now you'll see that you only have one critical value of 11. After getting a critical value, then draw a number line. Draw a number line there, ladies and gentlemen. After drawing a number line, indicate your critical values on the number line. The smaller one, remember that this does not, I said if it includes something underneath, you must shade in your number line, but it does not. So I'm going to put open circles. We're going to put open circles there. Okay, open circles. And then the smaller critical value on the left. But in this case, we only have one critical value. We don't have two critical values. So I cannot say if there were two critical values, the smaller one was going to be on the left, the bigger one on the right. But in this case, it's only one critical value, which is 11. So I'm just going to indicate that critical value in the middle here, shaded 11. Okay, that's the critical value that I'm going to put there. Okay, then I'm going to, now you can see that if we had two critical values, according to the procedure, we're going to have 3 regions. We're going to divide our inequality, our number line, into 3 regions. But in this case, we have one critical value. So we're only going to divide our number line into 2 regions. There's going to be the region 1. This is all the values that are to the left of what? Of 11. This is going to be the first region. And then all the values that are to the right of 11, the second region. Okay, this one is the second region, because we only have one critical value. If we had 2 critical values, then we'll also have a region in between those 2 critical values. Okay, so we'll have 3 regions according to that. Then after doing this, we then choose a value that is less than 11, a value in the first region. So we then choose a value in the first region. So we can choose any value that is less than 11. We can choose 10. And then we come back to the factorized form here. Wherever you see x here, you're just going to replace it with the value that you chose. Any value in region 1, it's any value that is less than 11. So let's say it's 10. So we substitute x with 10. So if we say 10 minus 11 in the brackets into 10 minus 11 again, we get 10 minus 11, it's negative 1 times negative 1. Negative 1 times negative 1, it's a positive 1. So we are interested in the sign. The sign is positive. You then indicate the sign in the first region is positive. Okay? Then we go to region 2. Region 2, it's all the values that are to the right of 2. All the values that are to the right of 2. So we're just going to choose any value that is to the right of 11, not 2. Sorry about that. All the values that are to the right of 11, that's region 2. So we choose any value that is greater than 11. We can choose 12. Then wherever you see x in the factorized version, you just come and put 12 there. You just put 12, 12, 12. You just put 12 here. Okay. Then you get a 1 times another 1. Okay, 12 minus 11, it's 1. 1 times 1 is positive. So we get a positive again. Okay, then after getting those signs, you then check your original problem. What was the problem even? You go to the factorized form with this step here, where you factorized and then you made it greater than 0. You look at this sign, you then check this sign here. The sign is greater than 0. Greater than 0 means positive. Greater than 0 means positive. So you go and tick where there is a positive in your region. Okay, where there is a positive in your region. You can see that in region 1 here, there is a positive. So you tick there. There is a positive in region 1. Also region 2 has a positive. So both regions, they satisfy the what? The origin, this problem, because it's greater than 0 meaning positive. So both the regions, they satisfy. So when you write down the solution, you just say therefore, you just say x, you just write x, and then the arrow, it's the answer is in the first region as well as the second region because they both satisfy. You look at the arrow in the first region, which direction is it pointing? It's pointing that way. You just point it that way, the same direction that the first region, the arrow in the first region is pointing, this white arrow here. You also point your solution there. Okay, then you put in the number, so it's 11, and then you say or, you say x. You look at the second region, also it satisfies because there's a plus sign there. You point the arrow, the sign in the direction of the arrow. It's pointing that way. Then you put the number 11 and then you are done. This is your solution to the original inequality there. Okay, this is the solution to the original inequality there for 4 marks. Okay, that's how you actually do this inequality. So let's look at the second example again. Example 2 here. So in example 2, they give us this one. They say x squared minus 4 is greater than or equals to 5. Okay, again, when you look at this, you can see it does not follow a standard form type of a quadratic. So you must first get a 0 there. Okay, so you must take it. So you're going to say x squared minus 4 minus 5 bigger than or equals to 0. Okay, and therefore your x squared minus 9 is bigger than or equals to 0. Now you must then factorize this quadratic here. But when you look at it, these are difference of 2 squares. Okay, so you must then factorize it. You put it as 0 on the right, so the only thing you need is to factorize. Now you know how to factorize x squared minus 9. This is the difference of 2 squares, dots, difference of 2 squares. So you then say x minus 3 into x plus 3. You must know how to factorize there. Okay, and when you are here, please don't say x minus 3. Look at the procedure. Don't say this or this. It's very wrong to do this. Don't do that. Okay, according to the procedure, you must get the critical values of these. Okay, you have to get the critical values of these. So you're just going to say critical values. The critical values is going to be x. You take each bracket from the procedure. They take each bracket, equate it to 0 and solve. So you get x equals to 3. Positive 3, and then you take the second bracket, x plus 3 equals to 0, then your x is negative 3. So you have got 2 critical values there. After having your critical values, just draw the number line. Okay, and then look at the inequality. It includes here, when you look at the inequality sign here, it also includes the what? This sign in between. So you must shade when you indicate your values there. They must be shaded. Okay, they must be shaded there. Then the smaller critical value between 3 and minus 3, you have 2 critical values as you can see here. You have positive 3 as well as negative 3. So the smaller one on the left, the bigger one on the right. Okay, that's according to the procedure. And then now you can see you have 3 regions. The first region is to the left of these 3. The left of minus 3 is the first region. This is region 1. The second region here is the region in between here. The second region is the region here. This is the second region. Okay, region 2. That's the second region. The third region is the one that is to the right of 3. So the moment you have two critical values that are different, you are going to get 3 regions. The first one, we had only 2 regions because we only had 1 critical value. But in this case, we are going to get 3 regions because our critical values are 2. So you have the region to the left of the smaller critical value, the region in between the 2 critical values, as well as the region to the right of the bigger critical value. Okay, so this is what we have. And then after having this, you then choose any value in each region. You choose a value that belongs to that region. Okay, so let's start with region 1. Any value that is to the left of -3, which is, we can choose -4. Let's say -4. We then come back and substitute it back here where we factorize. So we're going to say, where you see x, you just put -4 minus 3 into -4 plus 3. And then you want the sign. So -7. The first bracket is -7. The second bracket is -1. So we get a +7. So we're interested in the sign. So in this region, we got a plus sign, a positive sign. And then after doing that, you go to region 2. You then test a value in the second region. So after testing a value in the second region, you are going to choose any value that lies between -3 and 3. Let's choose 2. Okay, 2, it's in the second. Any value that is between the 2 values, we can make 2. So you go where we see x, we just replace with 2, not -2, 2. Okay, so we just say 2 minus 3 into 2 plus 3. First bracket, -1. Second bracket, 5. So the final answer is -5. We're interested in the sign. The second region is negative. We then go to the last region, the third region. Okay, the third region. What is the third region? It's the value started to the right of 3. So we're going to pick any value that we can think of that is to the right of 3. Let's pick 4. So wherever you see x, you just put 4. Okay, so you then have 1 multiplied with, this is 7, we get a positive sign. So we get a plus sign there. Okay, so we have now our signs. Our signs is what we are interested in. We're not interested in the numerical values of what? Of the answers, the numerical values rather. We're not interested in the numerical values, but the signs. Okay, then we go back to the factorized version here, here. We look at this sign, greater than or equal to 0, but the focus is on the greater than sign. It means we want where we have positives. So we're going to tick the regions that satisfy that. Okay, so you can see that the first region is positive, it satisfies. The second region, no, it does not satisfy, but the third region satisfies. So that's the answer is going to be in the first and the third region. So we just say, therefore, x answer lies in the first region. So we're just going to say less than. There is the value that is here, it's -3. Remember that our original sign had this, had a greater than or equals to. Also, we must, when we indicate our solution, we must not forget that equal sign underneath there. Okay, underneath this. Okay, but the arrow must point in the direction of the inequality sign. Rather, it must point in the direction of the arrow of the region that we are interested in, which is the first region. So it must point to the left. Then we say, or our x, we are also interested in the third region. The second region, I'm going to minus it because it gave me a minus, which we're not interested in because we want greater than. So we're going to skip the second region. We're not going to represent this, but we're going to represent the third region. X must be greater than, we just put an equal sign because also our problem includes the equal to the, okay, then it's 3, this value here. Then we are done. This is how we represent our solutions there. Okay, that's how we write it down in the exam. Okay, just be careful here. Don't write and here. Just write or, not and. Don't write not and. Don't write and. Okay, so in the second video, I'm going to look at example 3 as well as example 4. Okay, example 3 and example 4. Thank you very much.